Okay, what are the trig ratios? Let's start with explaining what a ratio is first. A ratio is simply a comparison between two numbers. Often we set a comparison as a fraction. For example, if you got 7 out of 10 for a test, what's the 7? 7 is what marks you got, compared to 10 is what the test was out on. See how 7 over 10 is a ratio comparing two numbers? That's what SOHCAHTOA are. They're also ratios. The trig ratios are simply a comparison of two sides of a right angled triangle. And what did we do in the past lesson? We labeled those two sides, well, those three sides. So these ratios are useful because they allow us to find unknown sides and angles in a right angled triangle. Have you seen SOHCAHTOA before? You've heard of this. But do you know where that comes from? That's what I'm going to come in and do. In any right angled triangle that has an angle of interest theta and the sides opposite, adjacent and hypotenuse, sine theta is the ratio of opposite side to the hypotenuse side. So you would have seen this. Sine theta degrees is equal to opposite over hypotenuse. Get that down. That first one. Cosine of theta or cos theta is the ratio of adjacent side to the hypotenuse side. So that's what you'd have in your cheat sheet. Cos theta is equal to adj over hyp. And last one, the last ratio that you need to be aware of at year 10. There's more ratios that you'll learn about if you do spec or methods next year. The last one is tangent of theta, or tan theta is the ratio of opposite to adjacent. So tan theta is equal to op over adjacent. Hopefully now you can see where SOHCAHTOA comes from, because if I underline S, O, H, that's SOH. If I underline C, A, H, that's Ka. And if I underline T, O, A, that's TOA. That's to help you remember these ratios, so that instead of, okay, you could write all of that on your cheat sheet, but if you can cover it with just that and having experienced practicing answer these questions, that's going to be a more efficient use of your cheat sheet space. An example. So for the following right angled triangle, I want to find sine of theta. Should we label the sides first? Which side is going to be opposite in that scenario? Which one? The 3, the 4, or the 5 one? Which one is opposite? 3. Which one is the hypotenuse? Hyp. And which one is adjacent? 4. So sine theta is equal to opposite over hypotenuse, because it was SOH. What is the opposite? It's 3 over 5. You can leave it as 3 over 5, or you can work out what 3 over 5 is in your calculator as a decimal. Cos theta adjacent over hypotenuse. That's going to be 4 over 5. And tan of theta is going to be opposite over adjacent, which is going to be 3 over 4. I think that's 0.6. I think that's 0.8. And I think that's 0.75. Can I get that example down? Then you can have some time to work on the